So welcome everybody to this latest A-level video on 162 Maths, and in this video we'll be looking at trigonometry with a focus on small approximations. So if we look at the trig graphs in radians closely, and in particular when theta is small, so what area we're talking about, so let's get a different colour pen. So this graph here is sine x or sine theta, and we've got x going along the horizontal axis. So what I'm talking about is if x is small, so we're looking about like this region here. If I took a closer or zoomed in on that graph, then what we'd notice is that this graph resembles what would look like as a straight line. Now that straight line is probably not great, so let me just draw that a little bit more accurately, like so. Let's just change it so it actually resembles what we're looking at. So it always looks like a straight line. Now again, looking at the angles, so this is what we've got. We've got sine x and we've got x. And this line here resembles x. So and this is y equals x. So if spotted y equals x, and this red line here is resembling, or approximately you could say, is y equals x. Now if we do the same for the other trig graphs, so here we've got cos x, so let's just get different, and so cos x, and instead what we're going to do is we are going to zoom in on this area here. Then what that then generally resembles when theta is small is this line here. So this is cos x, this is x. And we could say that this line here is approximately resembling, let's say, like a quadratic, and the equation of that line is 1 minus a half x squared. And also with tan x, and we've got x, if I zoomed in on the area where theta is small, so this here, then that, very similar to the sine x graph, just basically resembles what we class as a straight line, and that is supposed to be a straight line. And again, we can say that this is y equals x. Now, basically what this is generally about, you might be thinking, what on earth are you on about? Why do we actually do this? Is imagine that your sine, cos, tan buttons do not work on your calculator. Now, if theta is small, then it is possible to get an answer for theta without actually using the sine or the cos or the tan button on your calculator. So this is all about doing trig without using your buttons on your calculator. So when theta is measured in radians is very small, basically what's classed as small is when theta is less than 1. You can approximate the value of sine theta, cos theta or tan theta by using these small approximations. Now these approximations formulas are something that used to be given to you in a formula book, but if you're not given a formula book, then you will need to learn these sort of formulas. And let's just get them for that one. And again, these are something that you need to learn. Now the key thing with this is that we are always approximating, so this is why we've got our little curly equal sign. And when dealing with these approximations, what you're actually doing is you will be swapping. So let's get this and call it pen. Purple will do. So what you're doing is you'll have a trig function sine theta, and what you're going to do is you're going to swap it with wherever theta is in the sort of approximation. So here I've got theta, so and then I'll swap that for this bit here. So all you're doing is replacing the tan theta with where theta is in the approximation formulas. Again, let me just highlight those, so that whatever this is, let's just delete doing that. So whatever this is, that's going to go here. Whatever is there is going to go replacing there, and whatever is there replacing there. And the reason why I do that is because these approximations can be used to approximate more complicated functions which could involve sine, cos and tan as multiples of theta, where you can assume these multiples of theta are also very small. Now the key thing is to make sure that you apply the approximation to everything inside the trig function. So here I've got sine half theta, so what I'm going to do is have that approximately half theta, because if you look back at the original formulas, that sine theta is approximately just theta when theta is small. With cos 2 theta, all I've done here is I've replaced the theta part in the cos 2 theta with the theta that's in the formula. So I'm not multiplying, even though I've got cos 2 theta, I'm not doing, let's say, this, where I'm doing 2 lots of 1.5 theta squared. It's just this that needs trace swapping. So whatever is in the bracket, if you put it like, if you let's say you had cos, let's say 30, put the 30 in bracket, and that is what you replace with theta in these approximation values. And again, moving on to tan 4 theta. Well, because tan theta is just approximately theta, then that just remains the same like so. So let's have a look at some of these example questions. Now, the most important thing to establish is make sure your calculator is in radian mode. And that's really important going forward with some of these questions. So this first one, it says use small approximations for cos 0.2 and find the actual value. Now for this, we need to recall what the approximation for cos theta actually is. We know that cos theta is approximately 1 minus a half theta squared. So that's what I'm going to be using. Now all I'm going to be doing here is replacing this theta with this theta. So here I know that I've got cos 0.2. Oh, I don't know why a little line through that, so I'm just going to change that. I've got cos 0.2 is going to be approximately 1 minus a half, and it's going to be 0.2 squared. So all I've done is I've replaced this theta and put it into this theta. Now if I then go on to actually work that out, so I've got 1 minus a half times 0.2 squared, I get an answer of 0.98. Now in terms of the actual value, this is where I actually need to substitute it in. So the actual value is typing in cos 0.2 into my calculator. So I've got cos of 0.2 equals, and I get an answer of 0.98006657778. And you can see in terms of comparisons of these two values that my approximation to 2 decimal places is pretty spot on. So in my approximation, it's just given me 2 decimal places, whereas my actual value is a irrational number. We can see that they are very, very close. Now, sometimes you might get asked to work out what the error is. So the error is going to be 0.98 minus 0.9800665778, in which your answer is going to be minus 0.000665778. And there is the error in this. So it's actually underestimated rather than overestimated, and that's something that you may get asked. Now this question didn't ask for that bonus part, but if you did, hopefully that clears up as to what it is they're asking. So let's have a look at our second example. So this says find an expression for the approximation of f theta equals 4 theta tan 3 theta when theta is small. Now in these particular questions in exams, you'll never get, now one question I got asked when I taught this was, when do you know when to use small approximations? Well, it will literally tell you in the question, so don't worry about, do I use this all the time or not? It will give you some indication of when this is, so it'll either tell you that theta is small or tell you to use small approximation. And that will apply to all the questions involved in this particular topic. So starting with this question, I'm going to write down the expression. So I've got 4 cos theta tan 3 theta. Now, just a reminder, I know that cos theta is approximately 1 minus a half theta squared, and tan theta is approximately just theta when theta is small. So these are the expressions that I'm going to be using. So from this, what I then got is I've got 4, and then I'm going to swap the tan in there. So I've got, let me just write this further down so I've got a bit more space. So I've got 4, so that stays the same. Then I've got 1 minus a half theta squared. So this is my cos theta that I've substituted in. And then I need to substitute my tan 3 theta, which is just 3 theta. Let me just change that to a different colour. So I've got 3 theta, and that's basically what this is approximately. So the next thing I then need to do is just simply expand the brackets out. So you expand the brackets out, I've got 4 minus, it's going to be 2 theta squared, and that's all multiplied by 3 theta, which gives me 12 theta minus 6 theta cubed. And there is my final answer. So this is the expression for the small approximation of 4 theta tan 3 theta. Let's have a look at our next question. Now this question is kind of like a twofold. but we can do it in a similar way. So again, I need to write down the expression for sine 3 theta plus cos 2 theta plus tan squared theta. Now again, sine theta is just approximately theta, cos theta is approximately 1 minus a half theta squared, and tan theta is approximately just theta. Now again, just writing those down in the corner when you're doing these will help you remember them just a little bit clearer. So again, I've got sine 3 theta plus, I'm trying to use different colours, cos 2 theta plus tan squared theta. Now tan squared theta is also basically tan theta squared. So that's where we're dealing with from there. Now from this, what we then got to do is look at this. So we've got sine 3 theta is just going to be 3 theta plus 2 cos theta. Well, that's going to be 1 minus a half, and it's going to be 2 theta that's being squared. And then I've got plus, and it's going to be tan theta is just theta, then the approximation of tan squared theta is just going to be squared theta squared I should say. So expand the brackets and simplifying this, I get 3 theta plus, and I'm not going to simplify this too much, but I've got 4, and then obviously 2 theta squared is going to be 4 theta squared times a half gives me 2 theta squared plus theta squared. Then expand the brackets out, I get 3 theta plus 1 minus 2 theta squared plus a theta squared, which equals 3 theta, and it's going to be plus 1 minus theta squared. And there's my approximation. Now the next part then says, hence find an approximate value for the smallest positive root of the equation of this. Now this, even though I've replaced theta with x, this is basically my part A. So what I've got is I've got that this is going to be equal to 3 theta plus 1 minus theta squared equals 1.5. Now this is slowly looking like a quadratic, so what I'm going to do is I need to make it equal to 0 before I go on to solve. So taking all of that to one side, try and keep theta squared positive, I get theta squared minus 3 theta, then I've got 1 minus a half, which is going to be plus a half equals 0. Now from this, what I then want to do is I then want to go on to solve this equation. Now again, so you can solve this by either using your calculator to solve using calc, or by using the formula in which I get that theta equals 2.82 or 0.18. Now the question asked me to work out the smallest positive root. So the smallest positive root is this one. So it is still important that you write down the two answers, but your final answer for theta is going to be 0.18, and that's to 2 decimal places. And there is my final answer. So, and there we go. Now if you want to practice this particular topic of trigonometry a little bit further, then I will include a worksheet with a set of answers in the description below. Now there was one question which is a more extensive question on the worksheet, which I'll now go through. So from this question then, what we want to try and do is, it says when theta is small, find an approximation for this particular expression. Now when you end up with something quite sort of looks quite complicated, and what I would do is I would take each section separately. So I'm going to write #1 for the numerator, and I'm going to write #2 for the denominator, and just deal with them separately. So in terms of #1, what I've got is I've got cos theta minus cos 2 theta. Now from this, all I'm going to do is just swap my thetas and replace it with the thetas in the approximations. So what I've got is I've got 1 minus a half squared theta minus 1 minus a half, and it's going to be 2 theta squared, close bracket. Now from this, I expand the brackets out, so I've got 1 minus a half theta squared minus 1 plus, then here it's going to be, well, 2 theta squared is going to give me 4 theta times a half is going to give me 2 theta. And then from this, what I can then do is go on to simplify this. So here I've got 1 minus 1, which cancel out. So let's just get a pen that cancels that out. And then I've got half, take away plus 2 theta, and that leaves me with 3 over 2 theta. So this is my numerator. Then dealing with hashtag 2, it's going to be a little bit more complicated. So my denominator, I've got 1 minus bracket cos 3 theta plus 3 sine theta tan theta. And just swapping them through, I've got 1 minus bracket cos 3 theta is going to be 1 minus a half 3 theta squared plus then 3 sine theta is just going to be 3 theta, and tan theta is just another tan theta, so I'm just going to put times theta, close bracket. Now from this, what I've then got is I've got 1 minus and then a half 9 theta squared plus 3 theta squared. Then from this, what I've then got is I've got 1 minus bracket 1 minus 9 over 2 squared theta plus 3 theta or 3 squared theta, and then expand the brackets out. What I end up with now from this, if I was doing non-calculator, which is really no need, well, I'm going to do it anyway, plus 6 over 2 theta squared, just so I can join those two fractions up. And then what I've got is I've got 1 minus, and then minus 9 plus 3 is 3 over 2. I forgot a theta squared there. Theta squared. And then expanding the brackets out, the 1 minus 1 plus 3 over 2 theta squared. The 1's cancel out, leaving me with just 3 over 2 theta squared, and that is my denominator. Then bringing it all together, I end up with 3 over 2 theta over 3 over 2 theta, which just simplifies to give me 1. And there you go.